Hi guys, let's do a very quick introduction to Racket, which is going to be our excuse me, our second programming language for this class. So we're going to be using two programming environments or two programming languages for the discrete math class. We're using Mathematica and we're using Racket. And the best IDE for Racket is is the Dr. Racket IDE. Now, sometimes I use Racket within Terminal using the Emacs IDE. I think for most of you that's going to be very, very difficult. So it's probably best if you just stick with Dr. Racket. I think it'll be much easier for you. Um, Dr. Racket has, well, Racket, the Racket language, because it's descended from Lisp, uses a lot of parentheses. And one of the things that's really nice about Dr. Racket is that it helps you keep track of all of those different parentheses, okay? So that's a big advantage of Dr. Racket. So that's why a lot of people like it. It does help them keep track of their opening and closing parentheses. And you'll see what I'm talking about in just a few minutes. So let me make sure I've got everything we need here. Let's click on Dr. Racket. Okay. And I think the current version is 8.1. Okay. Let's see what we have here. So, okay. And actually, it might be helpful. Um, Let me look at an example in your homework. So let me just open up, I think I'm going to open up your second homework assignment. Let's put this in a context. It's easier to explain this stuff if we're actually trying to solve a problem. So let's go, what's going on here? Okay, there we go. And let me go over here. Let me go right over here. My courses. Okay. It really doesn't matter which section I go to. They should be very similar. They should be almost identical, actually. So I'm in the 8C2 section. It doesn't matter because the homework assignments for the 8C3 students is exactly the same. So if you're an 8C3 student watching the video, don't worry about it because your homework assignments are exactly the same. Same questions, same assignments, same everything. The only difference is you're not actually logged in for a live video lecture, but you can watch those lectures at your convenience, and in fact, you should. I strongly recommend that you do that. Okay. Um, let's go to chapter 2, and let's see what we have here. Should we? Well, okay. Let's see. Um, let's do the student assignment view. Let's do the student view. I'll pretend to be a student. Okay. Okay, I want to go a little deeper into the homework. This is the set builder stuff. Oh, wait a minute. Can't I? Um, ugh. Oh, here we go. Okay. Let's go into I want to go deeper into the homework. So let's say, I don't know, problem 69. Yeah. I want to answer a sequence, a question with sequences. Um, Here, okay. Um, okay, so we could try, well, okay. So this is one possibility. Um, okay, well, this question's a little bit easy for our, okay, this is kind of an easy question, but that's okay. So I'm looking at problem number 76 in chapter 2. The terms of a sequence. So note this is a multi-part question. Once an answer is submitted, you will be unable to return to this part. What are the terms A0, A1, A2, and A3 of the sequence AN? I'm assuming, okay, so I'm assuming when they say A0, they're starting with index 0. That's kind of confusing because in some books you start with index 1 and in other books you start with index 0. Just like in programming languages. In Mathematica you start, lists are indexed with 1, but in Racket and Python and Java and C++ and a lot of languages, lists are indexed at 0. They start at index 0. Same with arrays. Do you start at 0 or do you start at 1? So it kind of depends on the programming language. But I think we're starting here with 0. This is actually really, really easy. So, but if we do it in Racket, maybe it's not so easy. So let's go back to Racket. So let's see. We have an is equal to 2 to the power n plus 1. And, okay, let's go to Racket. Let me make sure. Okay, 2 to the power n plus 1. Okay. Let's go over here, and I'm going to define... Oh, do we have... I believe the function is xt. xt 2 to the power 3. xt 3 to the power 2 is 3 times 3. Okay, so it's going to be expt. So if you just type exp, that's the exponential function. Okay, but we want expt. expt. So we can define the function here. Define a, n is my argument. And let's see, let me go back here one moment. So that is 2 to the power n plus 1. 2 to the power n plus 1. That's going to be expt 2n plus 1. Or you could put the 1 here. I mean, it really doesn't make a difference because addition is commutative. Okay? Let's see what we have. Okay, and I would like a list of answers, so I should probably define another function as well, right? So how about, let's see, define my A list, start and stop. Okay, so my starting index and my stopping index, and this may look a little complicated, but let's give it a whirl, okay? If my start is greater than my stop, give me back an empty list. Now this is how you represent the empty list in Racket. Okay, brackets, and then inside the brackets you have the constructor list, or you could do it this way. Now what is that symbol called again? That's the quote. That's the quote symbol. Quote symbol and then opening and closing parentheses, right? So either way, you can do it this way, or you can do it this way. Your choice, because they're really the same. They're really going to be the same. For some things, you really have to do it this way. And for other things, you can do it this way. Because sometimes that quote symbol, that quoting symbol, this is the quoting symbol, the quote symbol. Okay, Q-U-O-T-E. Okay, for some things that can get a little tricky. In fact, I think you can actually type it like that. Okay, quote. For some things that can get a little tricky because sometimes the quote will automatically apply to everything inside your list, and well, that can be a problem for certain things. Okay, so sometimes you have to do it like this, but you know, for this problem, it really doesn't make a difference. Okay, now cons means that I'm attaching something to the front of a list. It's called cons, C-O-N-S. Okay, it means I'm attaching an element, a number, or something else to the front of a list. So cons, A starts, A list, start plus 1, stop. Close all the parentheses. Let's give it a shot, okay? Run. A list. Okay, let's go back here. So 0, 1, 2, 3. 0, 1, 2, 3. 0 to 3. So we're going to have 2, 3, 5, 9 as the answer. 2, 3, 5, 9. So let's see. 2, no. 2, 3, 5, 9. Here we go. 2, 3, 5, 9. Yay, it's correct. Okay. Looks pretty good to me. Let's try the next one. For the sequence, an is equal to n plus 1 to the power n plus 1. The values of the first 4 terms of the sequence are a0, a1, a2, a3. Okay. All right, Chach, we'll go outside soon. Sorry, guys, I'm talking to my dog. I do have to take him outside soon for a walk. So the video is going to be kind of short, okay? So here we have a similar question. You know, an is equal to n plus 1 to the power n plus 1. Okay? All right, hold on one second. Hold on. Just hold on, guys. 1 second. Okay, we'll go outside soon. You gotta wait. We'll go outside soon. All right. Okay, so he's an adorable dog, but a little high maintenance. Anyway, okay, so this time what I'm going to do, guys, I'm going to change my A-list function. Actually, I'm going to get rid of this. Let's get rid of that, okay? And this time, let's create a more general function. Let's create a more general function, okay? So here, I'm going to put in func. Func is going to be a variable, right? And it's going to be, it's going to be some function that we're going to supply to the function A-list. So here what I can do, well, there are several ways of doing this. Let me see. I'll do it this way. This is how you, let and let star. I don't want to do let star in this video. Okay, we're just going to do let today in this video. This is one way of defining a local variable in a function. Okay, so let's func value is what I'm going to call it. You can call it whatever you want. I suggest using variable names that make sense so that later on when you open up your source code, you will be able to read your functions and understand what you did. So func value is going to be func start. Okay. And here, instead of a start, we're going to have func value. So let me make sure we're okay here. Let's indent. I'm just pressing the tab key. You don't have to indent. I think you should, guys. Otherwise, after a while, your code is going to look absolutely ridiculous and very hard to read. So you indent with the tab key. At least you do on a Mac. With Windows, it should be the same. I don't use Windows very often, so I'm not 100% sure, but it should be very much the same, okay? And then, okay, let me make sure this makes sense. We have a function named aList, or let's call it funcList, or, yeah, we can call it whatever we want to call it. So funcList, func start stop, let the func value be equal to func start. If start is greater than stop, we have the empty list. Or cons, func value, oh, this doesn't make any sense. Here we go. I have to change this. Func list, start plus 1 and then stop. It looks good to me. Okay, everything looks good here. Okay, so let's try it for the last problem. Okay, func value. Oops, okay, wait a minute. My cursor got out of control. Lambda, what letter do I like? What letter of the alphabet should I use? X. Okay, expt 2 to the power x. And this is plus 1. So that's my lambda function. Also, you can always do this, guys. You could do, let's see, how do I insert my lambda? Insert lambda. Okay, that's the Greek letter lambda, which means you're defining what's called an anonymous function. 0, 3. Oh, sorry. Escape P. Func list is what I called it. Oh, of course. Okay, this is the problem. Func. There we go. Let's start over again. Okay, let's try this again for the previous problem. So func list. Okay. This is a shortcut way of entering the lambda symbol on a Mac. Control and then the backslash. Okay. And I like X, and that's going to be expt 2 to the power x, and then that's plus 1, 0, 3, 2, 3, 5, 9. That's the previous problem. Let's do the current problem. The current problem, hold on one second. Let's see, an is equal to n plus 1 to the power n plus 1. Okay, so that's going to be func list lambda control backslash. You can use T. I don't care what letter you use, your business. Okay, expt. So we're doing, by the way, in case you're not sure, n plus 1 to the power of n plus 1. Okay? That's what we're doing. But we need to use Racket syntax, otherwise this is simply not going to work. So this is going to be, let's see, expt n plus 1. Okay, that's n plus 1 to the power of n plus 1. And what's the starting index? What's the stopping index? Let's see, 0, 1, 2, and 3. Again, 0 to 3. Okay, 0 to 3. Okay, what is going on here? Oh, you know what? Wait a minute. Hold on one second. Okay. No, this. Why is this not working? Oh, of course, of course. Okay, this function's working fine. The problem, my problem is right over here, guys. Here we go. I'm using variable t, and I decided to suddenly change over to n, which is really stupid. Okay, so either this has to get changed to n, or these have to get changed to t. That was very stupid of me. Okay, so hold on one second. Okay, so let's try this again. Escape P. Okay, since your book is using n, I'm going to use n as my variable too. And then don't worry about shift enter, just enter or return. Okay, we can ignore this. So the answer is 1, 4, 27, 256. Okay, 1, 4, 27, 256. Let's see. Okay, why? Oh, I see. Okay. 1, 4, 27, 256, and that should be correct. Check my work. Okay, and that's correct. And so, guys, it's important to remember, you know, if you get the problem wrong, there's no need for you to email me and ask me for another chance. You have unlimited attempts. You have unlimited attempts on the homework. So you can, you know, you can do the homework, you can do the problem as many times as it takes to get the right answer. Okay? So if you have to do the problem 10 times, that's fine. Whatever it takes to get the right answer. So I'm not just giving you one attempt. I actually could if I really wanted to, but I'm not quite that mean. So I'm giving you unlimited attempts. So you can do the problem over and over and over again, right? I also believe you have, let me see, you have some help options as well. Although for some reason I don't see them on this page, but you do have some help options, right? All right, let's go to the next problem. Let's go to 78. The terms of a sequence. So this is called the floor function. This is the floor function, okay? The floor of 1, for example, is 1. The floor of 1.5 is 1. The floor of 1.9 is 1. So it finds the least integer that is, how can I say this? It finds the integer, it finds the maximum integer. It finds the maximum integer that is less than or equal to a number. So in other words, it always rounds down is what the floor function really does. The ceiling function does the opposite. The floor function finds the maximum integer that is less than or equal to a number. So that's the definition of the floor function. FL, here, let me spell it for you. The floor function. And its complement would be the ceiling function. So the floor, you know, if the floor function is abbreviated to F, the floor of 1 is equal to 1, and the floor of 2.8 is equal to 2. So you're always rounding down. You're always throwing away the decimal part, okay? That's going to be the floor function, right? Okay, so let's go back to this. Let's go back to Dr. Racket. Okay. So let's see, what is our new function here? Floor function. Okay, so, and what are the indices from 0, 0, 1, 2, and 3? Looks good. Okay. So let's do func list. Okay. Lambda, or I can insert my lambda, whatever. Insert lambda. Okay. N. And it's the floor function of n divided by 2. And we're going from 0 to 3. So that's 0, 0, 1, 1. 0, 0, 1, 1. So 0, 0, 1, and 1. And let's check the work. Okay, looks really good. And let's just do one more, guys. Okay. Find the first 4 terms of the sequence given below. So we have the floor of n divided by 2 plus the floor of n divided by 2. Well, we could, well, okay, I have a feeling it's just going to be 0, 0, 2, 2, which makes sense, but we'll make it official. Okay, we'll make it official, but I'm pretty sure it's going to be 0, 0, 2, 2. So func list, and then let's see, control backslash n, and so we're going to have plus the floor of n divided by 2. Oh, wait a minute. Floor of n divided by 2 from 0 to 3. And that's going to be 0, 0, 2, 2. 0, 0, 2, 2. So that's going to be 0, 0, 2, and 2. That's interesting. Why? Oh, this is the ceiling. Oops, sorry about that. This is the ceiling function here. I thought it was the floor function. Okay, that's the ceiling function. Let's try that again. Okay, let's try that again. This is the ceiling function. It's either ceil or ceiling. Let me see. Okay. Yeah, it's the ceiling function, not the floor function. The ceiling function is the opposite of the floor function. So it's 0, 1, 2, 2. Sorry, it's not. Okay, I'm going a little too fast here today. So 0, 1, 2, 3. 0, 1, 2, 3. Okay, so that should be 0. Why can't I type over this? Return to question. 0, 1, 2, and 3. 0, 1, 2, and 3, and that should be correct. Check my work, and that is correct. So the first 4 terms of the sequence starting at index 0 are 0, 1, 2, and 3. Yeah, from a distance, this looked like they're just adding 2 floor functions, but it's actually the floor function plus the ceiling function. So, okay, that makes sense. Okay, this will be our last one, guys. Okay, this is going to be the last one. The sequence that begins with 2 and in which each successive term is 3 more than the preceding term. The first 10 terms are, okay. Well, this is obviously going to be 2. I mean, let's get some practice with Racket. So, I mean, this is obviously going to be 5, and this is going to be 8, and this is going to be 11, and so on and so forth. But let's uh, let's do this with Dr. Racket. Okay. I'm going to define a new function. So let me see here. Well, actually, I'm wondering if we could use our previous function. Let me think about this a moment. 2 plus 3 times 0 is 2. 2 plus 3 times 1. 2 plus 3 times 2. Okay, maybe we could use our previously defined function here. I'm pretty sure that's going to work. So func list, okay, lambda n plus 2 times 3n, going from 0 to 9. Yeah, if we start, so we're going to start with 2. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 3 is 14. 14 plus 3 is 17. 17 plus 3 is 20. 20 plus 3 is 23. 23 plus 3 is 26. And then 26 plus 3 is 29. So it's simply 2 plus 3 times n. 2 plus 3 times n. Eleven plus 3 is 14. 14 plus 3 is 17. 17 plus 3 is 21. 21 plus 3 is 24. 24 plus 3 is 27. And 27 plus 3 is 30. Hold on one moment. That feels like, you know what? Okay, I think I goofed. Wait a minute. Oh, of course, yeah. 17 plus 3 is not 21, sorry. 17 plus 3 is 20, so this has to be 23. I forgot how to add. Great. I need a computer program to add. I'm like, how do you add? So 23 plus 3 is 26, and 26 plus 3 is 29. Okay, so we start with 2. 2 plus 3 is 5, and then we have 8, 11, 14, 17, 20, 23, 26, and 29, and it should be the correct answer. Okay, terrific. So this is just a simple introduction. There's a lot of other stuff in Racket. There's a whole lot of other stuff in Racket, okay? But this is a nice introduction. It should get you started. Now you have an idea of what Racket looks like. So Racket takes some getting used to because you're not going to do, 2 plus 2 plus 2, right? So Racket is like, what are you doing? Racket doesn't quite understand this. I think what you might be able to do, well, most Racket programmers don't actually do it this way, but let me see if this will work. Yeah, so you'd have to do something like, and then you would have to do this again over here, which is just kind of weird. So yeah, that's really not what Racket programmers generally do. What they'll do is simply this. Okay. So yeah, doing it this way here is a little crazy. I don't recommend it. This is the real Racket way of doing it. Okay, this is the real Racket way of doing it. Now the problem is it's not going to work if you have a list of 2's. Right, that's not going to work. But you could do something like this: apply the plus function to 2, 2, 2. Okay, and that will give you the same answer as plus 2, 2, 2. Okay, you can apply it to the list. You can apply your function to the list. So, for example, range 1, to 11 will give you the range of integers from 1 to 10. And if I want to find the factorial of that, I could do apply times range 1 to 11. And that's the factorial of 10. That is 10 factorial. So up here, for example, I could define my function, define factorial of a number, cond. Cond is like if, then, else, but it's a little more general. So, okay, 1 second. Equals if n is equal to 0, give me 1, because 0 factorial is 1. If n is equal to 1, okay, also give me 1. Or we don't have to make it recursive. So this is, I'm not going to use a recursive definition, although I could. That would be very easy. I'm going to do apply times range 1 plus n plus, okay, n plus 1, which is plus n1. Let's see if that works. Okay, so what is the factorial of 0? It should be 1. What is the factorial of 1? It should be 1. What is the factorial of 5? Okay, that's not quite... Why am I getting that as an answer? Because, well, you can either use the keyword else or just write true. That's the symbol for true. Okay, yeah. I kind of goofed. Here, let me, hold on 1 second. So, here we go, apply. There we go. Okay, now that makes more sense, because otherwise it's like, Racket's like, what are you doing? Okay, so if n is equal to 0, give me back 1. If n is equal to 1, give me back 1. Otherwise, so you can write true or else, right? You can write true or else. Otherwise, give me back the result of apply times, range n plus 1, which is right over there. Okay, let's try that again. Okay, factorial of 0 is 1. Factorial of 1 is 1. Factorial of 5 is 120 because 1 times 2 times 3 times 4 times 5 is 120. Remember, range 1, 6 gives me the list of integers from 1 to 6. So factorial of 10 gives me back 3,628,800. Okay, now what if I want to do I want a list of factorials, right? I could do something like this. Define factorial list n. Okay, let's see. If 0 is greater than n, error, or could we say argument input? I'll make it simple. Error, bad argument, enter a non-negative integer, please. Okay. Otherwise, well, here, let me do it like, I forgot my parentheses. Okay. Otherwise, for list, I'll use the letter I. We all love I, don't we? range, let's see, 1 going up to n, and we're going to do factorial of I, and we're going to run that, and let's see what we get. Factorial list, oh, actually we should start with 0. You know what, this really should be 0. Let's start this again. Okay, and factorial list -4. Bad argument, enter a non-negative integer, please. Okay. Factorial list 10. There you go. So the factorial of 0 is 1, the factorial of 1 is 1, the factorial of 2 is 2. The factorial of 3 is 6, the factorial of 24, the factorial of 3 is 6, the factorial of 4 is 24, the factorial of 5 is 120, the factorial of 6 is 720, the factorial of 7 is 5040, the factorial of 8 is 40,320, the factorial of 9 is 362,880, and the factorial of 10 is 3,628,800. Okay? And I think here we could actually do, let me see, let me just do a little experimentation. Argument, input error, I think that's okay. Or is it argument error? Yeah, okay, I think it's argument. Is it argument error? Okay, let me see, because I think I forgot that. So, Google, raise error in Rackets. Raise error in Rackets. Raising exceptions. Now, hold on one moment. Where is this? Because it should be... Yeah, but there's another way of... Okay, hold on 1 second. Raise user errors is another option. Oh, raise argument error. Right. Okay, raise argument error. So we could do... No. Raise argument error. Okay, hold on. Let's tab that over a little bit. Let's tab these over. Okay, that looks nice. Okay, that's an alternative if you want to start doing a lot of exception handling, right? So we could do, okay, so, excuse me, factorial list -5. Raise argument error arity mismatch. The expected number of arguments does... Oh, so, okay. Racket is yelling at me here. Why is this an issue? Oh. Raise user error, actually, or raise argument error. So the name expected. Okay, so name is symbol expected... The name is a symbol, expected is a string, and let's see, v would be any value. Okay, so here, okay, it doesn't like, okay. So here, oh, come on, let me, there we go. So here, this is a symbol, bad argument, error, and then I would have to provide, here, let me put this over, okay. Bad argument, error, or bad argument, enter a non-negative integer, please. And this would be, one moment. Let me see, this would be exact, okay, bad position, okay, exact non-negative integer. This would be exact non-negative integer. Okay, let's give that a shot. Okay, so now we would have factorial list negative 80. Contract violation, expected, bad argument, enter a non-negative integer, please. Or here, actually, for the message, okay, so we're getting a lot of weird syntax highlighting here. Okay, so expected, zero or a positive integer. There we go. Okay. Define factorial list. Okay, so raise argument error for the symbol n, and what we're expecting is 0 or a positive integer. Exact non-negative integer question mark. Okay. If 0 is greater than n, so if n is negative. Okay. And let's see. And we can't have decimal values either, actually. So factorial list, let's see, negative 80. N, contract violation expected, 0 or a positive integer given, procedure, exact non-negative integer. Okay, or factorial list 80. Well, let's do a smaller number. Well, you provide a smaller argument because these numbers are going to be very large. So let's say display ln. Yeah, the numbers are really, they're quite big. So factorial of 50. Oh, sorry. Factorial list 50. Okay. So, yeah. And we start with 0. Factorial of 0 is 1. Factorial of 1 is 1. Factorial of 2 is 2. And you get the idea, guys. I'm not going to go through the entire list because that's exhausting, right? So you get the general idea. I mean, we could actually handle, this in a separate function. So if I wanted to, let me see, helper, and we could say define factorial list, sorry, okay, with handlers. Now let me make sure I'm doing this correctly. So we have a lambda expression, and we have an error function. I'll say, hey, we're going to go outside soon. You're going to have to wait a moment, okay? Just wait. And this is, let's say, an exception. I'll call it exc or exn. How about exn? Exn, okay. And, okay, one moment here. Okay, let me make sure I remember this. I experiment with a lot of different programming languages, guys, so it's easy to forget some of these things. So, oh, you know what I'm missing? Okay, hold on. This part is correct. It actually is correct, but I am missing. Hold on one second. Actually, hold on one moment. I just want to see something very quickly. Okay, it's easy to forget this. Where is my linalg file? So cat linalg.rkt. I want to see something here. Yeah, we have an exception failure clause. Yeah, there we go. Okay. There we go. Okay. So here we're going to have exception. It's either fail contract, okay, or it could be exception contract fail. I forgot which one. It's either we could do fail, exception fail, and then here, if we do have a failure, what do? Then we're going to display ln. Input argument must be 0 or positive integer. Oops, sorry. Positive integer. Okay. And we're going to do factorial list helper n. Okay, and I believe that should work. Factorial list 12. Now, what if we deliberately enter a negative value? Yeah, input argument must be 0 or positive integer. And actually, instead of using exception fail, let me see here. I believe I could also use contract fail, or is it fail contract? That I don't remember, but oh, okay, so yeah, it's not accepting this. So we could do fail contracts. Racket should compile that. And then we have factorial list, let's say 15. Okay, that looks great. And what about factorial list negative 15? Right, input argument must be 0 or positive integer. Now don't forget, we didn't handle the case where n is a decimal value because that's not acceptable. Okay, so I don't think that's going to work. If you have range 1, 10.5, oh, okay, actually that sort of does work because Racket just ignores the 0.5. But really, guys, you're not supposed to take the factorial of a decimal value. Chach, we're going to go outside soon. Okay, guys, my dog really needs to go outside, and I need to get going. I think the video has gotten long enough. So you have a general idea of what's going on. How long has this video been? Oh my goodness, it's almost an hour. Should we go over one more thing? I think really, guys, that's enough. I think that's really enough. So, excuse me, we can go over other stuff. So we can go over other stuff, but I need to get going. So we'll go over other stuff during the video lectures during the week, Monday, Tuesday, Wednesday, Thursday. By the way, as a heads up, June 28th, I'm going to have to cancel the lecture for June 28th. All right, so that's a Monday. So June 28th, guys, I'm going to have to cancel the lecture for June 28th. But that's just one lecture. And if you have issues, questions about a homework problem or whatever, just email me. If you're not sure about using Racket, the online documentation is pretty good. YouTube offers a lot of Racket tutorial videos. You can find everything on YouTube. I mean, YouTube has everything, including programming tutorials, okay? And some of them are very good. If you're having a problem with what I'm doing here, if this looks crazy, like what is Mr. Lewitt doing? I don't understand. use YouTube as a reference because you can find a lot of programming tutorial videos on YouTube, and some of them are excellent. Some of them are very, very good. So here, yeah, how would you test if you're dealing with an integer? Okay, so here, number Mr. Lewitt. We know Mr. Lewitt's not a number. That's a string, right? So that's false. Number 3, okay, that's true. Number 3.2, but that's also true. So actually what you would have to do, let me see here, equals 3, floor of 3, that's going to be true, equals 3, floor of 3.2, but that's also going to be true, so that's really not going to work. Yeah, that's going to be false. Okay, so the reason is because the floor of 3.2, yeah, the floor of 3.2 gives you back the decimal value 3.0 or 3.0, but 3 is actually going to be an integer. So you could do something, you could, if you're going to handle the case of decimal values, let me see here. So you could do or equal n, floor n, not okay, so let's see, factorial list. Okay, guys, sorry, I'm distracted. I'm listening to stuff that's going on in the kitchen right now. Factorial list 10. Okay, factorial list -10. That's not going to work. Factorial list 10.2. There we go. So that's not acceptable either because you're not supposed to take the factorial of a decimal value. You have to take the factorial of 0 or a positive integer. So yeah, this actually works pretty good. You know what I should do? I'm just going to email this file to you. I'm going to save this. All right. I will save, let me see. Yeah, I think we're going to just save this file. And that way, you know, you can refer back to it. Let me see here. So, what should I call it? Yeah, 78 is ridiculous. Can you change that, please? Thank God. I know I'm recording, but that's, I can't believe she did that. Sorry, guys, I'm talking to a relative. Yeah, so that's, okay. So we're almost finished. Let me just save this. So what should I call this? Video lecture for, okay, 06, June 6th, 0606 2021. 0606 2021. I like to give my Racket files a blue tag. That's just what I choose to do. So, okay, so let me make sure everything is okay. And let's do Racket and video lecture. Okay, so you know what? Let me get rid of the zeros here. Hold on one second. Well, actually, I do need them. That's okay. That's okay. I'll leave that alone. Why is, let's see, video hyphen lecture hyphen 0606/2021. You know, let me put in another hyphen. Hold on a second. Maybe that will. Nah, that doesn't do it either. Okay. It's just a long name. There's really not much I can do to shorten that. Here, you know what? Instead of video lecture, let's just say lecture. Okay? That should be a little bit better. Lecture dash or hyphen 0606/2021.rkt. Racket files always have a .rkt extension. And yeah, that's a little bit nicer. Then I can see the entire name in my folder, right? So we have lecture dash 0606/2021.rkt. Let's open this with Racket. Everything looks good, and we can do run. It compiles. And I'm going to add a comment. Racket file for video lecture. Oh geez. No, I do need that #lang Racket at the very top. So Racket file, let me put my laptop on my desk, 1 second. So Racket file for video lecture on June 6th, 2021. Racket file for video lecture of, actually that's better English, of June 6th, 2021. Okay? And just a couple more spaces here to make it look nicer. And let's see what we have here. Add a couple spaces. Easier to read. Okay, that looks fantastic. Let's save the file. And let's open this one more time to make sure we're okay. Click on Dr. Racket. Click on Dr. Racket, and then let's open that file. Open recent file. And we're going to run it. And it looks good. And let's test it one more time. Factorial list -10.3. Input argument must be 0 or positive integer. Factorial list -9. Input argument must be 0 or positive integer. Factorial list 12. And there you go. You have all the factorials from 0 to 12. Okay, you have all the factorials from 0 to 12. And factorial of 12 should be this number right over here. And that looks great. Okay, I think that's enough. This is a 1-hour video, and actually a little more than 1 hour. And I think we've done plenty, okay? So thanks, everyone. I will talk to you on Monday morning. And if you have questions, just send me an email. Take care. Have a wonderful day. Bye-bye.